So in addition to being able to solve quadratic equations by factoring, we also need to be able to write quadratic equations when we're given roots, given answers. I'm going to walk you through a few problems in doing this. So the roots of the quadratic equation are what x equals when you solve it. So the first thing I would do is take these two answers, and I would say, hey, x has to equal 5, and x has to equal negative 1/2. Now, my idea in getting the quadratic equation, I can solve by factoring, but just sort of like getting everything on the same side, factoring, breaking it up into two things using the zero product property and the solving. What I'm doing now is the exact reverse of this. So I've got the two answers. So what I want to do is get the two factors that gave those answers. So to do that, I'm going to move everything over to the same side. And then these are the two factors that we had in our original equation before we broke it apart using the zero product property. So now I could keep this as x plus 1/2 equals 0. I think I'd rather have pretty numbers. So if I take this entire equation and I multiply it by 2, that will get rid of the fraction, and I still have a factor that when I set it equal to 0, it would give me negative 1/2 as an answer. So this is a factor, and this is a factor. So now I'm going to take those two factors and multiply them together, and then I'm going to FOIL them out. Now, this is now a quadratic equation that has these as roots. Now, if you didn't get rid of the 1/2, you would still get something that works. You would get x squared minus 9/2 x minus 5/2 equals 0, which is basically this equation divided by 2. Now, if you look at this equation that I've got, if I divided the whole thing by 2, I do it to both sides, it's still. All right, so process again is to set x equal to each of the roots, find the factors by moving everything to the same side, multiply those factors together, and then write your answer. So here we go on the second one. 3 plus or minus the square root of 5 over 2. So if I take these two roots, one of them is 3 plus the square root of 5 over 2, and the other is 3 minus the square root of 5 over 2. And these probably came from the quadratic formula, right? But we're still going to use the reverse of the reverse of factoring to sort of like get what this quadratic equation is. So the first thing I'm going to do is multiply both sides by 2 to get rid of the fractions that I've got, because I want it to be pretty. I don't want to have to deal with those fractions. I'm going to move everything to the same side to get the factors. And now my two factors are this and this. Now don't let that freak you out. I know those are a lot bigger than the first ones we did, but this just has 3 terms in it, and this one does as well. So I'm going to use a box this time to multiply it out, instead of just using FOIL. So I'll take my first factor, and my second factor, and now I'm going to start filling in all the factors. Filling all the boxes. So 2x times 2x is 4x squared. This is negative 6x. And don't let this box scare you. 2x times negative root 5 is just negative 2x times the square root of 5. Negative 6x, positive 9, positive 3 square root 5, positive 2x root 5, 3 root 5 positive, and then negative square root 25. Now, when I go to combine like terms, 4x squared, cool. No other squared terms. Negative 6x and negative 6x, cool. Negative 12x. Now, since I had this plus or minus thing going on up here, this should always happen, which you're about to see. Negative 2x squared root 5, positive 2x squared root 5, they go away. 3 root 5, negative 3 root 5, they go away. Basically, I won't have any square roots in my final thing as long as these were conjugates of each other when I started, and they were. So then I have this 9, and then this negative square root 25, which is negative 5. So 9 plus negative 5 is 4. And then that would be your quadratic equation. Now, if you've gotten something that's a constant multiple, like if you had gotten 2x squared minus 6x plus 2 equals 0, that would be fine. X squared minus 3x plus 1 also would be fine. Now, let's do one more, but this one will involve i's. Fine, right? Same process though. X equals 5 plus 3i root 4, 3i over root 4, and minus. Get rid of the fractions to make it easier. Get everything on the same side behind the factors. Multiply it out, and since there's 3 terms in each thing, I'll box it. First factor, second factor, fill in the boxes. Look for the things that have i's to simplify or cancel. So I got a negative 12ix and a 12ix, a 15i and a negative 15i, and then I squared is negative 1, so this negative 9 times negative 1 is going to give me a positive 9. So when I combine like terms, I have 16x squared, minus 20x is minus 40x, and then 25 plus 9, which is 34. So that would be an acceptable answer, or you may have even gotten 8x squared minus 20x plus 17. Heck, you could have even gotten like x squared minus 20 over 8x plus 17 eighths. All of those are possible answers, and any of those would be correct.